on automating bug bounties with Ansible. I don't have a ton of experience with bug bounties. I've just kind of recently started looking into them. But I do have quite a bit of experience with Ansible, both at work and on personal projects. And it is my go-to tool for um, uh, infrastructure automation. So if you look at the Ansible website for a description of how it describes what it says Ansible is a radically simple IT automation engine that automates cloud provisioning, configuration management, application deployment, inter-service orchestration, and many other IT needs. That's pretty accurate. It can pretty much cover the entire continuum of things that you'd want to do. Um, I think especially for bug bounties, it's going to help scale in a way that is difficult to do otherwise. And especially with the complexity of the things that you have to do with bug bounty, having a simple IT automation framework, I think really pays off in the long run. But hopefully you'll join me and see how far down this rabbit hole we can get with automating bug bounties with Ansible. Ansible works basically, you can run ad hoc commands with Ansible, but it's usually ran based on a series of playbooks. And these playbooks are YAML files. They look like this. They have these, start off with these 3 dashes and then a set of YAML lists. YAML is a data serialization language, very much like JSON. And if you use tools like Kubernetes or Helm, you'll be used to YAML files. They're kind of how a lot of the modern tooling kind of it's very common to use YAML in modern configuration languages and cloud configurations. And Ansible uses YAML as well. So you're probably be familiar with this if you have a background in doing any of those types of things. But basically YAML is a set of configuration files, and it looks like this, which is basically each YAML file is considered kind of like a playbook. And it's a series of tasks that's kind of run from top to bottom. And they specify a module, and that module takes certain parameters. This is the example of a variable. You can pass in variables to them, and they can reference variables and things like that. And they execute basically from top to bottom as they're defined in the playbook file. This, I think, is a really key, an important feature of Ansible. That when it fails in a very deterministic way. You know exactly where it failed, and you know exactly what's been done up to that point. Unlike tools like Terraform or Puppet that generally have these state files with dependency graphs, Ansible doesn't do that. Your dependencies have to be very explicit, and they're very clear. They are not hidden in some sort of state file or dependency graph that's hidden away from you, where you may have a failure, and the failure may actually be due to some missing dependency or some change dependency that's far remote from the configuration that you touched. Ansible, where it fails, that is the configuration that is broken, and it's pretty easy to see what's causing the issues. So I think that's another really big benefit of using Ansible over maybe some of the other automation tools that are out there. But yeah, basically Ansible also provides the ability to extend it via modules. You can write your own Ansible modules. Usually I write these in Python, but pretty much as long as they return JSON, it should work, but I usually stick with Python. But you can extend it and add your own functionality to Ansible as well. So Let's see. So if you're familiar with like Terraform, this would be like your ability to write a Terraform provider. This is very similar. This is the modules that Ansible uses, and the modules basically wrap a set of functionality, the code, actual code, as opposed to the declarative configuration. So the declarative configuration is the use of modules. So in this case, it would be like the service module or the yum module, and you're basically passing in these parameters to code that is going to use these parameters to execute the code that's inside of the yum module, or parameterize the code that's inside the yum module, or that's inside of the service module or the template module. And you can create your, like Ellie says, you can create your own custom modules as well to extend it. But it comes out of the box with a bunch of different modules. This is just like a very small sampling of what kind of modules it supports. So AWS, GCP, F5, VMware, NetApp, Juniper, Cisco. But it comes with a wide range of built-in modules that are of varying quality. So your mileage may vary with each one. But you can also, you'll see you don't really need to use all these most of the time. You can accomplish a lot with just the basic shell module. But yeah, so that's a brief overview about what Ansible is. So I'll show you how to get it installed on a Parrot OS machine. I'm using Parrot OS because I've used it in the past, and it's kind of built off of a vanilla Debian Ubuntu machine. So I think you'll probably have less issues with Ansible and running its built-in modules on Parrot as opposed to Kali. I can't say that for sure because I've never tried it on Kali, but given the degree of modification of the Kali OS, I just suspect that this would be the less painful way of using Ansible for bug bounty. So that's why I chose it. And so let's get started. So the first thing you'll want to do is you'll want to install virtualenv. That will allow you to create a Python virtual environment so that you don't mess with your local Python installation. So virtualenv doesn't come by default on Parrot OS, so you have to install it. And you basically do that just by running sudo apt-get install python 3-venv, and that's the package that will install. It's already installed on mine, but I'll walk through the steps. You can see that it's Python 3-venv is already installed, and is the newest version. But that's how you would install your virtualenv tool. And the next step is that you'll want to actually create a directory that will house your virtual environments. And usually I just do mkdir, my home directory, and then pym. So when I run this, it's already there, so it's going to say the file already exists, but if it didn't already exist, it would create it. And then you'll just cd into your pyms directory. And here is where you're going to create your virtual environment. And you just do that by running python 3-venv. And in our case, I already have an Ansible and I already created, so I'm just going to do Ansible 2 just so you can see. And then it creates the Ansible 2. I already have Ansible, and Ansible 2 is what I named it, but you can just name yours Ansible. So just run the same command, just like that. Okay. So you should be left now with an Ansible virtual environment on your machine, and then you just want to activate that virtual environment, and you do that by sourcing deactivate script inside of the bin directory of your virtual environment. And when you see this little parenthetical Ansible or environment, this is just saying that you're already in that virtual environment, and so now all of your Python commands will be relative to that environment. And so this is where we're going to install Ansible. And you do that just at this point. You'll run Python dash pip install Ansible, and you'll run that, and it will install Ansible. It's already installed on my machine. So see, it's already satisfied. And once you do that, you should have available to you the Ansible executable. Your Ansible version shows which config file you're using right now. It by default doesn't have one. There's a whole host of settings you can set in that configuration file, which we're not going to use right now. It also shows you the default where it's going to be looking for modules. So if I write like my own modules, I could put them there. Here's where all the kind of the built-in module paths are located inside of Ansible. And then there's these things called Ansible collections, which is just another way of kind of organizing configurations and code together. And it's kind of a newer way of doing that, as opposed to kind of some of the older ways that used to be available. Jinja is the templating engine that Ansible uses. So if you saw over here, like this example where it says contact that item, that's a variable that, and this is like the Jinja 2 template variable. So the Jinja 2 engine can read this YAML file, and it sees these as a variable, and it's how these variables get populated, like at runtime. So now we have basically a working Python environment. You can run Ansible, like I said, ad hoc, just on the command line, by executing like Ansible. Here would be the host name. We used to do localhost, and let's do like -m specifying a module. We'll say the shell module -a. It's passing the arguments that the shell module takes, and the shell module just takes like just a simple command. In this case, I'll do uname -a. You see I ran it, and if I were to run this out in the command line as well, you see it's the same output. So the same string gets output as if I were to run uname by hand. That's an example of running Ansible in an ad hoc way, but like I said earlier, most of the time you don't run Ansible in this way. You run Ansible playbooks, which is a way of collecting these tasks in a single place, related tasks. So they're basically steps, and they go from top to bottom, as we mentioned earlier. So you collect them inside of playbooks. So here's my parent playlist I've already created, and I have a setup YAML configuration file. And basically all YAML files have to start off with these 3 dashes at the top. And then this -hosts directive says that I'm going to run this localhost, and my connection is going to be a local connection. I'm not going to like reach out over SSH and try to connect. By default, Ansible will try to. Its connection is an SSH remote connection, so it tries to SSH into the host, and you can specify here a named set of hosts that it accepts. Like Ansible accepts a configuration file that has or hosts inside of it, and they can be host names, they can be VPN, they can be IP addresses, and you can name them, and it'll like you could say like all MySQL boxes, right, and have a list underneath that specifies like 8 or 9, 10, 20, 30 hosts, and you can just specify MySQL here, and it'll reach out to those hosts. If I didn't have this local connection here, it would reach out to them and try to connect them and run things on them. And you can do this on your remote machines in the cloud, and you can do this on remote machines that you have or other machines that you have SSH running on, that you have access to. But that's a different thing. We're not going to worry about that right now. Right now, we're just worrying about, kind of getting Ansible installed and starting on automating the setup of our bug bounty workstation. So this configuration here, this is a Ansible secrets file. So there are many places where Ansible like evaluates variables or tries to resolve variables. And one of those is the secrets file. The thing that separates a secrets file from a normal variable file is that the secrets file using Ansible Vault is how you generate these secrets files, is that it is AES-256 encrypted. And so it's really a place where you store true secrets that you want to remain private. And so you wouldn't commit this to source control. You would basically you can commit the other variables that are not secret to source control, but if you have secrets, you wouldn't want to commit this really. But if you did, it is AES-256 encrypted, and so it wouldn't be going in plain text. But it is a place where you store secrets, and it adds an extra layer of protection around running Ansible and passing in sensitive information that you want to keep secret. And basically at runtime, it evaluates the playbooks and it like decrypts, and then in memory will replace the variables that you specified with your secrets if they're present. So if it finds that secret name inside of your task here. So inside of each playbook, as you see, there's a series of tasks. Here I just have one task, and this is it from this dash down to here. And this name here is basically a name for the task, like what I'm executing. And if I was going to execute more than one, I could put many of these one after the other. But this is just the first one, and its name is add bug hunting default role. And basically what I'm doing here is I'm importing a role. And the role that I'm importing is a layer. And a role is just a collection, it's just a set of directories with a collection of configurations in them that are supposed to be related. So it's kind of a way of saying, I want this, it's a place where you can collect certain configurations that provide a certain let's say a certain role to a machine. If I wanted to make it a MySQL machine. So in this case, I'm making it my layer or my bug bounty machine, and so it's going to have a set of configurations that are designed for my workstation. You can also supply tags or tag these tasks with tags that you create. So I just defined it as bugs, and just adding it here is defining it. So I don't have to put it anywhere else. As long as I just tag it here underneath this tags, and this is now a task that's tagged with the bugs command. Or the bugs tag. If I have another task, it could be no bugs, right? And I could, if I only wanted to run tasks that had this bugs tag, I could pass it into the Ansible Playbook command and have it target only tasks that have this bugs tag, and it would avoid running all the other tasks that did not have the bugs tag. By default, if you leave it off, it just runs from the very top of the playbook down to the bottom of the playbook, executing all tasks that it comes across, no matter what tags they have. So assigning the bugs tag does not remove it from basically the default all tag. You can imagine that it basically all tasks is what is assumed if you don't specify a tag when you actually execute the Ansible Playbook command. So I'll show you an example of that. In this case, quickly I'll show you inside of roles. Again, it's just a set of directories with some configurations. The templates file is where templates, tasks, files, defaults. There are some others like meta, handlers, vars, other directories that you can include here. These are just the ones I kind of do by default, just out of habit. And I don't think I actually have anything in the main.yaml of the defaults right now. This is where like default variables go, and it'll kind of read that as a low priority or low precedent variable settings that I can reference in all these other, other areas like tasks and templates. Anywhere where variables are supported, I can reference them, and they'll be interpolated just like the secrets, only they're not encrypted. There's no encryption that goes on here. And it's a way that I can reference other variables that are kind of like sensible defaults for this module in case, for this role in case none others are provided. There are other places where you can override these defaults. That's why it's called defaults. But since I usually like to have my variables in a single place, I think that simplifies things. I try not to override things too much and just keep them all here in the defaults, main.yaml, or in the vars directory if I have to do it that way. But and this just gives a sensible set of default variables values for running this main.yaml. And this is the entry point to the entire role. So inside this tasks main.yaml, this is the one. So these directories could be missing. Like I could not even have this defaults or files or templates directory, and this would still be a valid role. But this tasks in this main.yaml file is kind of the heart and soul of a role, and it's absolutely necessary. And this is the entry point to. I can add other playbooks here. And this main.yaml can conditionally include them or just include them unconditionally. But it will always start by the very first task, top to bottom, running inside of main.yaml. So this is like a C program's main function. This is the entry point to the role. And so when it executes, I'm saying I want to run the layer role. That's just this directory. And it will look inside of the tasks directory in the main.yaml and start at the top and just work its way to the bottom of this file. So if I look at what is inside of that file, you'll see that I am creating the Jaeger bug hunting parent directory, and what this is doing is just going to go ahead and create a parent directory that's going to serve as kind of the workspace for my bug hunting on this workstation. It's going to using the file module, and the file module takes a path. In this case, I'm just a string that's my home directory Jaeger. So the Jaeger directory inside my home directory. It's going to create this directory if it doesn't exist. And here I said a state directory. That's how it differentiates if it's going to create a file versus a directory. And then the mode I'm going to put on is 075, which makes it readable and writable and executable by the owner, and then readable and executable by group and other. So this is kind of a standard Linux mode for directories. When I run Ansible Playbook, it's basically just going to run this one task inside of this one playbook. That will create this Jaeger directory. So I'll open a terminal, let you see that I'm not cheating. You see there's no Jaeger directory right now inside of my home directory. cd, so you cd into where the play directory where your playbook exists, that you're going to execute, and then I'll run Ansible playbook. And again, remember, you have to be inside of your Ansible virtual environment for this to work. But Ansible playbook, and then I'll go into just the playbook I'm going to run, which is setup.yaml, and then I have to run ask-vault pass because I added the secrets file. If I don't have the secrets file, then I don't have to run this ask vault pass. I don't have to add this. I can just leave that configuration out. Could just remove this section here, this bars file, just have connection and then tasks. You can just remove this entire section, and then you don't have to pass that in. But because I did, and it's going to be useful later, I'll show you in a later video how to create that. But right now, it's going to ask me for that password. I'm going to provide the password, and it would decrypt my secrets and then pass them into the playbook. As you see, it's saying it's running on localhost. It's gathering facts. So if you see it says OK2, that means it ran 2 playbooks or 2 tasks, and only one of them needed to change. So if I run it, so basically what it said is, okay, gathered facts, but that's okay. I don't have to run it. I've already done that, so I don't have to rerun it again. So it keeps track of what it actually had to run versus what it has already run. So if I try to run this again, you'll see that it's going to show that 0 have changed. Okay, so you see that this time 0 changed and said OK2, ran 2, and said 0 changed. So because Jaeger already existed this time, it didn't actually execute the creation again. It determined that it had already run. And this is a big thing in Ansible, is that it tries to be idempotent. So it tries to be that if you run it multiple times, kind of like an HTTP GET request, the state doesn't change. You're not changing any state by running GET over and over again. You're not changing any state by running something that's already been done over and over again. It will only do what it needs to do, or something that isn't already in the state that you said you wanted it in. And that's completely dependent on the module. It doesn't have to be that way, but this is a big emphasis in Ansible. The modules determine whether or not something is idempotent. Some people call it idempotent, but I call it idempotent because it's easier for me to say. But basically it means you can run this many different times, and you're not going to change the state by running it many, many times, right? So if I run it 1 time, if I run it 10 times, if I run it 30 times, the end state is going to be the same. Whereas if you think of something like Puppet, sometimes you'd have to run Puppet multiple different times, and it would be different every time you ran it. The end state of the machine could be different every time you ran it, depending upon what it detected at the time or not. In Ansible, that's not the case. Ansible, it tries to maintain idempotency, and so that every execution is going to be just like the previous execution, and you're not going to break things by running things more than 1 time. But again, that is up to you to maintain that. And so if you run things that are like the shell command, those will continue to be repeated. That's not everything, but there is a big emphasis in Ansible to do that. And the file module is one of those modules where it is idempotent. And so in the tools that I create, or the modules that I create, I like to maintain that idempotency because I think that's a big feature of Ansible. But there are some things that just you can't be idempotent, like you can't re-register a machine. You can't run that again. You can't. You have to run that 1 time and only 1 time. You can't run that in the future multiple times, because if you try to re-register a machine, you're going to get a different output, right? Oftentimes, like if you try to re-register a tool on a machine, or you try to re-register like a Red Hat machine, again, with its like satellite server or something, it would break because you've already registered it, and registering it again could cost more money or use up a license or something like that. And So not everything in the world is idempotent, but I really like that Ansible provides that framework and emphasis for doing idempotent tasks. Okay, so that's the introduction to Ansible on Parrot OS. You can see you can install Ansible on Parrot OS and it runs just fine, and hopefully this will be the beginning of automating our bug bounty with Ansible. So until next time, thanks for joining.